Hello, welcome to session 3J. This is Tim. He's going to be talking about anomaly detection for IBM Z systems and looking at it from a proactive issue identification using AI and machine learning technologies. So right out there on the leading edge. So please do remember to give feedback for the session. I have just put the session link in the chat, but from your bring your own agenda, you can also click on the link there to get to the feedback. We do use the feedback, so we would appreciate you filling that in. And you will all be on mute during the session. So if you have any questions, please put them in the chat. Tim can see the chat, so he can incorporate an answer as he goes along, or leave it to the end, depending on, I guess, what the question is. So with no more ado, Tim, over to you.
Great. Thank you, Anna, so much for the introduction. And thank you all for joining me today. I'm excited to talk about anomaly detection for IBM Z systems. I am the senior product manager for a product we call IBM Z Anomaly Analytics with Watson. And what I'd like to do today is, as a product manager, I always like to focus on the market challenges and the opportunities. And so I'm going to start out by talking about those topics. I also want to give a brief, introduction to the differentiation between your traditional monitoring solutions and how AI and ML and anomaly detection can help supplement those solutions. I will then talk about some exciting use cases that we've worked with our clients, deploying the solution into at our customers' shops. And then I'm going to end with an overview of our product and some of our hybrid cloud integrations with the Cloud Pak for Watson apps, because if we weren't talking hybrid, I wouldn't be at IBM. So do please add any questions to the chat, and I will answer them as quickly as I can. So let's start out with some of the market challenges and opportunities, right? Part of the reason why people are turning to AI for IT operations is because of the explosion in digital transformation and how businesses have transformed to use technology and data to streamline productivity and increase efficiencies, right? And so this data has become increasingly more available as machines and devices are connected and capable of transferring this abundance of data to really countless places, right? And this has allowed businesses to grow and to create new innovative products for their customers. But it has also led to this complexity effect that, it no longer becomes manageable for an individual to manually do all the data analysis to identify IT operational issues. And so the goal of these digital businesses is then to extract and analyze that information and make that discoverable from the data in order to reduce costs and downtimes. So this is where machine learning and data analytics can play a really big role in helping to proactively identify potential IT operational issues. And so what I am, focused on is leveraging, anomaly detection, using a series of tools and technologies to identify and address abnormal behavior as it appears in your data, in your IT operational data. And so these anomalies, right, that we can detect using machine learning can be indicative of suspicious events, malfunctions, defects. And so by applying machine learning to detect these types of anomalies, you can help to supplement your existing monitoring solutions by analyzing this, time series data in real time and helping to be more proactive when it comes to identifying issues and improving your service level agreements. So I want to talk a little bit about the difference between your traditional monitoring of time series data and what machine learning has to offer. So what I'm showing here is pick any sort of metric, or what we call a key performance indicator, right? You've got some zero value, some end value. It's usually a numerical value. And then you have some time, right? It evolves over time. It goes up, it goes down, it fluctuates. And traditionally, using, traditional real-time monitoring solutions, you've set these kind of static thresholds. And whenever your real-time metric in blue, right, whenever that real-time metric exceeds that static threshold, you generate an event, right? This is kind of the process for traditional monitoring. So how does this static threshold, be created, right? How do you set these thresholds? Well, traditionally, we've set these thresholds based off of subject matter expertise or tribal knowledge, or people that have experienced a problem, they've done the problem diagnosis, and they found that this particular key performance indicator is a problem signature for a bigger problem. And we should make sure we're monitoring that KPI so that we don't run into this issue again. So it takes this idea of bringing in and embedding tribal knowledge into your monitoring solutions and setting the static threshold. Now, this static threshold is super valuable, right? Based off of your subject matter expertise and based off your historical experience, you know that as soon as that real-time metric exceeds that threshold, you're going to have a problem. The issue with this approach is it doesn't scale, right? Skills and these SMEs that have been setting these thresholds, they could be retiring or leaving the market or going to a competitor. So how are you managing this? And this is where now we're looking at, well, what if we could apply machine learning to help us identify and understand what normal operations are for that particular KPI without needing SME domain knowledge? What if we could automatically generate thresholds using historical data? And so this is exactly what we are doing. And what we've seen is that there are a couple of really key unique values of using machine learning to supplement your historical or your traditional monitoring solutions. The first one is that you can get a lot more granular in your thresholding. Rather than having a static threshold, we can look at the seasonality of the data. We can differentiate what normal operations look like for a weekday versus a weekend. We can also look at the difference between a Tuesday and a Monday. And we can drive down into saying at a Monday at 8 a.m., this is what normal operations should be like for this individual KPI. And we can scale that. We can automate the analysis of this data to cover a lot more different KPIs than what you can do with a subject matter expert who's using traditional monitoring. And so what you're seeing down here is, for example, let's call this, metric A, and at time, hour 1, right? This is what normal operations should be like for your KPIA, right? At, number 2, this is what normal operations looks like. Number 3, this is what normal operations looks like. And what we can do is by adding on multiple layers of algorithms or logic, we can assign and try to identify potential issues sooner rather than later. So what we can do is we can say, okay, we breached this threshold at hour 2, but what if it was just a spike? What if it wasn't actually a problem? I don't want to be, inundated with a million new alerts through anomaly detection. I only want to be alerted of things that we're pretty confident that this is going to be a problem. So perhaps I don't alert on this, hour 2, but in hour 3, it looks like it's continued to trend upwards. It's starting to get more anomalous, and there might be a problem here. And then at hour 4, right, this is at T naught, this is when I'm going to generate alert, because I see a trend in anomalous activity for this individual KPI during this time frame. At this point in time, I think I'm going to send an alert out to the IT operator to say, hey, something's not right here. You should go check this out. And if you look at this, these two, traditional monitoring and the anomaly-based monitoring, it's the same metric. It's just that using machine learning, we've set different thresholds based off of normal operations, which have been built using historical data, versus a static threshold that's been set by an SME. So then the next question becomes, well, then how proactive is anomaly detection versus traditional anomaly detection? And so what I'm trying to show here is, again, imagine you are doing anomaly detection or doing monitoring without anomaly detection, without machine learning, right? At T0, you're going to see some sort of, I'll say, root cause or something, some symptom is building, right? And at T1, those symptoms continue to build. They're small. You're not really seeing a big impact. None of your traditional monitoring solutions are starting to, to fire off warnings. But once you hit T3, right, this is when you start to experience a significant failure. This is when your traditional monitoring solutions, you breached that threshold, right? Users are starting to notice maybe some degradation in your services. And so at T3, you're going to get this alert. And then at that point, you go through your incident management process and you start to diagnose the problem. And then you take another, undetermined amount of time to fix the problem. But the idea is that with anomaly detection, right, we're looking at all of these smaller abnormal deviations from your normal operations, and we're looking at the trend of it. And the idea and the theory is that with anomaly detection, we can alert once we start to see that trend of anomalous activity. We're not waiting for a big threshold breach or a significant failure. And by addressing these symptoms earlier, we can actually shorten your time to diagnose the problem and overall reduce the time to recovery or to fix the problem. So the idea is that by being more proactive in your alerting, it'll give you more time to diagnose, avoid the problem, and ultimately shorten your mean time to recovery in order to better meet your SLAs. So this is what we are hoping to achieve with anomaly detection. So how do we actually do this? Well, the first thing that we do is we need to collect your historical data for the subsystems and the KPIs that you want to monitor. And what we use is we use IBM Z's common data provider to batch load historical data into a database. In our case, we're using DB2 for ZOS as our database for metric-based machine learning. And then once we have access to that data, we use Watson machine learning for ZOS to analyze that data and build models of what normal operations look like for that historical data. Once we have a good understanding of what the models look like, the next step is to stream those live metrics using, again, common data provider. We're now going to stream those metrics in real time and score those metrics against our model for normal operations. And at the end of the day, what we do is we visualize the insights from those machine learning insights in a UI so that you can get a graphical representation of your real-time metrics compared against the historical or the normal model. So what does that UI look like, right? One of the things that we use in IBM Z Anomaly Analytics with Watson is this concept of a scorecard. And the scorecard shows you a number of different things. The first thing it's going to show you is your real-time metrics. So over here, you can see this kind of black line. This black line represents your real-time metrics for any number of key performance indicators that you're monitoring. Those shades of blue in this graph represent the model. So anything that is within this light bounds of shades of blue are what we consider normal operations. It means you have an anomaly score of somewhere between 0 and 40, right? It's somewhere within the normal bounds of your operations. The medium shade of blue represents low anomalous activity, meaning you're veering away from your normal operations. This is something that we should really start doing some trend analysis on to make sure that it's not evolving into something more, highly anomalous. And then the darkest shade of blue represents the high anomaly score. This is when if your real-time metrics have a high anomaly score that goes into the dark blue shaded region, we're going to send you an alert because this is outside normal bounds. you should take a look at this. And so we provide this level of anomaly detection for KICS, for DB2, MQ, and ZOS. And we have about 500 different KPIs that we support in the product today. And through collaborations with our customers, through staying up to date with our subsystem development teams, like our KICS or DB2 development teams, and making sure we're up to date on the different data that they're now generating on their next releases, we add and we expand the KPIs that we can support in our tool over time. And these KPIs, these 500 or so KPIs, we logically group them in what we call KPI groups. So for example, communication is one of the KPI groups, where then you can see, socket data, socket KPIs, or in-socket peak is one of the individual KPIs that we are looking at right now. And what it does is it actually, I'll give you another screenshot, but each one of these squares up in this grid represent the anomaly score of a given hour for a given KPI group. And you expand that group, and then you can see the anomaly scores for the individual KPIs that make up that group. So here again, you can see the real-time metrics, how it's being scored against the model. And then whenever you see a dark blue, right, we would have sent out an alert at this hour point. When you start to see the real-time metrics go into the high anomaly score, this is when we would send an alert. Now, we do not expect the end users of this solution to sit in front of the screen and watch these graphs. What we do is we actually generate alerts when you start to get a high anomaly score. And all of those alerts can be sent to whatever event management system you want, whether it's ServiceNow or NetCool Operational Insights, right? We support email, SMS, we do EIF, webhook integration, right? We can basically integrate with any of the event management solutions that your company uses today. But in addition to that, on this problem insights page, we keep a historical log of all of the anomaly events that have been detected with our solution. And when we generate an alert, we actually embed in that alert a URL that brings you back to the particular KPI during a given time period, for a specific, subsystem that you're monitoring. So one click to insights from the event that we've generated. And again, all of the events will be have historical reference in what we call our problem insights tab. So we've had a lot of really interesting and exciting, client use cases that are using this solution. We've looked at large US-based bank that had a transaction flooding and resource contention problem, where it was actually an application change that they made, and that they started to experience this transaction flooding and this resource contention when they deployed that new application into production. And what we were able to detect is right when they were able to start to deploy that new application, we were able to provide early warnings from multiple KPIs, as well as from our log data, that provided them with a holistic view of the potential problem that they were going to experience if they didn't change something right away. Large international airlines, they had this unexpected business growth, and they started to run into an out-of-disk storage situation. And one of our key KPIs was able to provide 48 hours of advanced warning of this out-of-disk storage situation. But one of the use cases that I kind of like talking about the most, because it focuses on hybrid cloud integration, it focuses on making sure Z is a first-class participant in our hybrid incident management scenario or use case, is this online. It was a online fashion retailer based out of the UK, and it was a Black Friday situation where they had this huge surge in transactions and they had unexpected workloads. And they had actually implemented the Cloud Pak for Watson AI Ops to manage this hybrid application, but they hadn't yet connected the Z Insights into their AI Ops platform to provide that mobile to mainframe visibility. So when they were looking at their application problems and they were trying to diagnose the problem, they were missing the source of the problem, which was that the DB2 database threads had exceeded its maximum threshold, and it was causing a slowdown on the front end of the application or the distributed side of the application. And what we were able to do through a proof of concept with the client was they sent us that historical data. We ran that data through ZAA and then sent the event to be integrated with the Cloud Pak for Watson AI Ops to take a hybrid incident management perspective. And we were able to reduce the mean time to resolve the problem by 43%, which ended up representing about $200,000 to $300,000 in savings had they implemented ZAA and integrated the Z Insights with their broader hybrid cloud management product. And so I've got a link here to a couple more real use cases. They do get pretty technical in nature, which I think a lot of our audience really appreciates. But we're going to continue to blog about these use cases and talk about the value of supplementing your traditional monitoring with anomaly analytics. So what I'm going to do next is I'm going to pivot. I'm going to start talking about the product and what it does, the features it has, and the value that hopefully you can start to see. So any questions at this point before I move into the product overview? All right. So IBM Z Anomaly Analytics with Watson, in my mind, has 4 key functions to it. The first one we talked about is building the model, right? Understanding what normal operations look like for your environment and being able to visualize that model in a graphical representation so that you can quickly interpret, how your real-time scoring is compared to that baseline model. The second key feature is we do anomaly detection for metrics. So looking at the SMF records for all of the different subsystems for DB2, for KICS, MQ, IMS, and ZOS. The third key feature is we also do anomaly detection for logs, for syslog messages. And it's a little bit different in terms of the algorithms and the logic that we're using for anomaly detection for messages, because now instead of looking at trends and bounds for metrics, we're now looking at the occurrence or the frequency at which different messages are occurring. We're also looking at the sequence of the system messages, right? Are things starting to fire outside normal sequences? And then the fourth and final feature that I think is really, really exciting, we've got a lot of great feedback on, is what we call our topology service. And this is the ability to visualize graphically the relationship of these anomalous activities on top of what we call our deployment configuration dependencies. So if you have KICS and DB2 and you're monitoring those, how are those related? How are those two subsystems related to one another? And how does anomaly in DB2 impact an anomaly in KICS? And how do you visualize that relationship? And that's something that we are providing with the topology service with the hopes of being able to accelerate problem isolation of this anomalous activity. And then, of course, everything that all the insights we generate through our machine learning and artificial intelligence, we make it integratable and extensible through events. And we also are able to correlate those Z events with distributed events so that you can get a hybrid perspective of your anomalous activity on Z and how that could impact the front end of your hybrid application. So there are a couple of key components that we use. So I already mentioned that we are leveraging IBM Z common data provider to collect and stream both the metric data, which comes from your SMF data, as well as your syslog data. And what we do is we actually are doing our syslog data running on Linux on Z or Linux on X. And that's where we are conducting our log-based machine learning. And then on ZOS, right, we're keeping your metrics data within the DB2 data warehouse to then perform metric-based machine learning using Watson machine learning for ZOS. And then the insights from both of those AI engines are then surfaced within what we call our problem insight server, or UI, our front end. And that can run on ZOS, it can run on Linux on Z, it can run on Linux on X, on x86, right? Run these insights where it will be the most valuable to your team. So as I mentioned before, with our metric anomaly detection feature, we do support DB2, KICS, IMS, MQ, ZOS. And what we've done is we've actually partnered with our data scientists, our IBM data scientists, and the subsystems teams that develop those DB2 KICS subsystems. And we provide what we call pre-built KPI models for each of those subsystems. And each of those models support the 80 to 100 different key performance indicators that our subsystem experts have told us these are things that you should have your customers look out for. And what we've done is then we're using, again, Watson machine learning for ZOS to then train the models that we've pre-built using your historical data. And then again, in real time, score those real-time KPI values against the model to then detect those operational anomalies and surface those alerts in the anomalous behavior, right? And that's when, we go back to our scorecard, and this is what the metric-based anomaly scorecard looks like, right? We talked about the real-time KPI metric, when it becomes an anomaly, and the different scores for the different timeframes that we support. So the process, right, I already mentioned before, this is kind of the data flow that we have for metric-based anomaly detection. But with message-based anomaly detection, we're doing things a little bit differently, right? It's a different data source. It has different data characteristics, and there's different algorithms and tools that we need to use to perform anomaly detection for syslog or log data, right? And one of the first things is we're building a model not based on the trends of, a metric over time series data. We're actually looking at all the different logs and trying to find patterns in those logs. So we're trying to determine, the frequency of particular messages, the clustering of messages. Do these messages usually come along with other messages, or are these mostly standalone messages? Are you expected to have 10 of these messages occur within a 5-minute time interval? Or is it anomalous if 20 of these messages occur within a 5-minute time interval, right? So we're looking at atypical frequency, and then also the sequence of message. Does message A usually occur after or before message B, right? And we're looking at the relationships of all of these thousands and thousands of logs in your historical data to generate these insights. And again, just like metric-based anomaly detection, we do not expect you to sit in front of a screen and watch this anomaly scores being generated. We send events and alerts that can then be grouped and correlated with other events across your IT infrastructure stack. Now, one of the big differences is that the data warehouse for log-based machine learning is actually shipped and included within the product. And so we are now using, again, common data provider to then stream those logs into our internal database, which is Elasticsearch and Kafka. And then we are training a model using, again, Watson machine learning for ZOS, training a model of that log behavior. And then, just like metric-based machine learning, we are scoring in real time and visualizing that model in a bit of a different way than with metrics. And if we look at the graphical user interface for the log-based anomaly detection, it's again a little different, right? You've got your timeline up here at the top. So each one of these boxes represents an hour of the day. We're looking at individual sysplexes and systems. You can also go back and forth in time. You can search for additional specific messages if you have a message that you're looking for. And then again, this red indicator means that you have a very, very high anomaly score at, what looks to be this 11:30 time marker. The other thing that you can do is you can highlight the time zones. You can see the anomaly scores. When you hover over a particular bar, you get additional information in context. Any AI, we have a question from Adnan, any AI support / integration on Z16 without streaming out data? So again, for our metric-based machine learning, that does stay fully on platform. This solution is supported for Z16. And if you want to keep it on platform, you can also do the log-based machine learning running on Linux on Z. And that log-based machine learning feature is containerized. So it makes it really quick to deploy the solution and get it up and running. Now, moving forward, the drill down experience, again, for log-based machine learning is a little bit different. So if you were to double click on this time in question, you get, again, high level system data. What was the actual data source being analyzed? What's the time interval? The number of unique message IDs that were identified during that time interval, and the highest anomaly score within that time. And down here, you get a list of all of the individual messages that have been grouped and clustered together that represent the highest anomaly activity. And so without sifting through thousands and thousands of logs within this 4 a.m. to 4:10 a.m. time period, you are quickly being surfaced the highest ranked anomalies during that time period. So in this column, you have your anomaly score, and you can start to see that it has a very, very high anomaly score of 99. 100 is the max there. The interval contribution score represents how how impactful this anomaly was to the overall anomaly score within that time interval. Was this particular message part of a cluster, or was it a unique message that has never been seen before? How many times did that message occur within this time interval? And you can actually see here on the timeline, the green lines represent how often that message occurred. And you can see the actual message that was generated. So we surface all of these insights into this UI without you having to do any digging, right? This is a really, really, really powerful capability. Our customers spend hours trying to find these insights, and within a click of a button, you can get to these insights. And this really, really accelerates problem diagnosis. Again, you can drill down into a little bit more detail. You can look at the periodicity of those individual messages. And again, filter back and forth on time, search for individual messages. So this is really just giving you some additional information about the message text summary and the individual message itself. So any questions about metric-based anomaly detection or log-based anomaly detection? All right, I'm going to move into the third and final core feature of Z Anomaly Analytics with Watson. And this is the topology service. Now, this topology service is collecting deployment configuration dependencies. This is a very, very different topology than what, most people think about from topology, right? When you think topology, sometimes people go to like application performance metrics or management, and you're looking at transaction tracing. what we're looking at in this topology service is how are all of your systems connected together based off of configuration dependencies, right? So what we then do is we visualize those relationships in a topology view. And on top of that topology, we actually provide status indicators or node decorators that can help tell you if you have anomalous activity on that particular component or subsystem within your environment, within your ZOS environment. And you can use that topology to then do more exploration of anomalous activity. You can use it as a navigation tool, and you can use it to really drill down. But the other thing, and one of the main reasons we include this topology service in ZAA is that you have to understand those deployment configuration dependencies in order to correlate your Z insights with your distributed cloud insights. So we're using this topology. We are sending it out through a file observer and being able to then integrate the Z topology with the distributed topology that's collected through the Cloud Pak for Watson AIOps. And this topology allows us to stitch those two, distributed world with the Z world together to get a holistic view of your hybrid application. And we use that topology to help correlate the different insights and data that's happening across your hybrid cloud environment. So what does that look like, right? So here's a screenshot of our topology view, right? First of all, you can see that we've highlighted this LPAR 400J. You can navigate to multiple LPARs. You can actually look at it from a sysplex. We support sysplex, ZOS systems, and also the subsystem relationships. We also are able to highlight DB2 data sharing groups, which is really important because if you're on Z, that you have a lot of shared nature of your subsystems, and that shared nature is important to have context about when you're trying to diagnose and isolate where the problem is. Because in the shared environment, like with DB2 data sharing groups, you might impact one or multiple DB2 groups where it's really just one anomalous event that's happening on one of them, but it could impact all of them. So you want to be able to visualize anomalous activity as it relates to the configuration dependencies of your overall Z environment. And then from this topology, right, we have this highlighted indicator. You can actually launch in context to that particular subsystem to then see the scorecard and then drill down into the individual KPIs that represent that KPI group. So you can actually start to see that. And you can again highlight or surface the scorecard for systems that are performing normally, because sometimes it's important to understand in the diagnostics process what is anomalous and what's not anomalous, because what's not anomalous might be just as important as an indicator of a problem than what is anomalous. So we give you the ability to see both anomalous activity and normal activity within our scorecards, and to use that topology to navigate the system. So any questions about the topology service? Okay. All right, I want to move on to hybrid, right? As I mentioned, IBM is all about AI and hybrid. And so I want to spend just a couple minutes showing you kind of what I've been talking about for a while, right? IBM Z Anomaly Analytics is just one solution that provides, proactive incident detection for Z. And what we are able to do is to, again, send our events and topology and integrate that directly into the Cloud Pak for Watson AIOps. The Cloud Pak for Watson AIOps is IBM's premier AIOps platform. And everything on this solutions for Cloud Pak for Watson AIOps takes a application-centric point of view, right? It is only trying to understand and to manage your most business critical applications. And we know that the most business critical applications within a customer environment, most of the time, always includes the mainframe. So we are making sure that the mainframe is a visible and first-class participant in your hybrid applications management solutions. And so the Cloud Pak for Watson AI Ops has like 100 or so patented deep AI learning algorithms that they've embedded into this solution. It is the thing that does all of this kind of cross data source correlation. And it also has this interesting, ChatOps user experience. And the reason that it's using ChatOps is because of the nature of hybrid cloud, right? We know that teams all control a little bit of this hybrid application. So they want to surface these insights in a medium where everybody can view the same information at the same time and collaborate remotely together. And so that's why they're using this ChatOps experience. Now, the second thing that we have is our IBM Observability by Instana on ZOS, right? This is where we've integrated our application performance management, our transaction tracing, right? And we're integrating all of those traces into Instana, which is the observability solution. And so then all of the events, topologies, and metrics from your observability solution also feed up into the AIOps platform. And in addition to providing Z insights for key trace data, we are also integrating key, or what we call our golden signals from an infrastructure perspective, from our traditional monitoring solutions or our Omegamons. And in addition to sending metrics into Instana, we also can integrate events directly into the Cloud Pak for Watson AI Ops. So overall, what we are doing is, from a Z perspective, we are evaluating the health, we are managing the health of your Z systems environment, this critical business infrastructure that is then going to support your hybrid cloud applications. And we're bringing that Z visibility into these application-centric management and AI tools. And so that is what we are really focusing on from a hybrid cloud integration perspective. So any questions about hybrid cloud integration? There are cloud counterparts taking an application-centric view, our Z team taking an infrastructure view, and integrating those two views together and using AI to derive insights. Any questions about the strategy or approach here? All right. So that is really the main content that I had for you today, but I do have a couple of call to actions for everybody here. The first thing is, test out these AI capabilities on your own, right? Use your own historical data. See the value that you can get by applying AI and ML to your IT operational data. And one of the main ways that we can support you with this evaluation is through a rapid proof of concept. Essentially, what you will do is you're going to need to figure out an incident that happened in the past and identify, a time period for which you want to analyze the data, right? And so you can identify this historical IT operational issue. You can send that data to IBM, where we will store it in our, secure infrastructure that includes our Anomaly or our machine learning solutions. And then we can run your historical data through our AI solutions and then demonstrate back to you within the product UIs, the insights you would have gained had you had this solution deployed in production during that historical time period when you had a problem. And that is one way where you can really quickly assess the value of our different solutions. And we accelerate the time to insights because you don't have to install the software in your own environment. We have it in ours. And it really is going to be a way for you to quickly evaluate the product, your specific use cases, and for you to see your insights. And so we have what we call our AIOps acceleration team, led by Catherine Hubley, whose contact information is here. You can also reach out to Lee Wang, who is one of our technical specialists She's the one that's working day in and day out with multiple clients. She's the one that's helping to, bring these use cases to light. And so this is one action that I would recommend you all take is, this is a free service, right? Let's check how your IT operational data can, provide you with greater value by using machine learning. My second ask is, this is a fast evolving space. We're doing a lot of really interesting, exciting, machine learning, correlation type of activities. And we're trying to make sure that we're delivering features to the market that are addressing your specific needs. And so we are launching our sponsor user program for a really unique use case that is starting now and going into mid-April. We're looking for about 4 hours of investment over those 3 months or 2 months to do more co-creation exercises, one-on-one sessions, look at our designs, validate our logic, take some surveys, and really help ensure that the features we're building are going to solve your unique business challenges. So if you want to get involved in our sponsor user program, Nadia is our lead researcher, and she is biting at the chomps to talk to more people about some of the innovative stuff that we're getting ready to release. And lastly, I want to leave you with a couple of links. To learn more about IBM Z Anomaly Analytics with Watson, you can visit our product page. You can also, again, I can't preach enough, the rapid proof of concepts, right? A lot of customers have taken advantage of this and seen a lot of great insights on how they could apply machine learning to their own data. And then lastly, we have an online community. You can reach out to me anytime by going to our AIOps on Z community. We have a forum. We've got blogs, videos, tutorials. All of our Z AIOps experts are part of this community, and it's a way where you can share ideas, make requests, learn about new capabilities that we're launching into market. So with that, I'd like to thank you so much for your time today. Again, I would like to open it up for questions for the remainder 10 minutes or so. But overall, thank you so much for your time. And if you do have any questions, feel free to reach out.
So you have all been set so that you could now unmute yourself. So if you want to unmute yourself and ask any questions, you are free to do that now. Adnan asked a question earlier. I assume you saw that, Tim. Yeah, good. And about the feedback, then please remember to put in your feedback for the session. As I said, it does really help us to organize the face-to-face and the next virtual conference to know what you like to see more of. So please do fill in the feedback. But now feel free to ask questions. Okay. Well, I'll end the session for everybody now. That he may notice that.
All right. Thank you so much, Anna.
Cheers. You're welcome. Bye now.
Take care.